Good evening, everyone. I hope you're doing very well. I thought I'd start in a very non-traditional way for TED speeches. Quick show of hands, how many of you here have a general idea of what a robot is? Okay, I expected that. At the very least, if you haven't seen a robot in person, you must have definitely seen them in films like Star Wars. You might have seen C-3PO. You might have seen droids like BB-8, TARS from Interstellar, to name a few. Robots, according to pop culture, are just your metal sidekick. They brew your coffee, they tidy up your mess, and eventually one of them turns evil and decides that humanity is the real issue, the very people that they're intended to serve. That's funny, isn't it? If you ask engineering textbooks, on the other hand, a robot is a programmable machine capable of carrying out a series of actions automatically. The funny thing is, by that logic, even your microwave would qualify as a robot. Which is not true, of course. There's a subtle difference between a robot and a machine. Here's a definition of a robot one of my friends told me that I find rather humorous. A robot is anything that moves on its own and might be secretly gunning for your job in the future. Unless you're working unpaid, of course, then you're probably safe. Am I right? In Dubai today, robots are becoming increasingly ubiquitous. They greet you in shopping malls, they deliver your groceries, they even file police reports. But let's be honest, some of us find fun in walking ahead of the robots, standing in front of them and seeing their reaction. This brings me back to my original question. What is a robot? To answer this question, let's go back to 1495, when Leonardo da Vinci sketched designs for a humanoid machine, a mechanical knight that could stand up, sit down, wave its arms, and move its head. He never built it during his lifetime, of course, but engineers centuries later would follow his blueprints. That's how long we have dreamt of building robots that act like us, move like us, maybe even think like us. Now in the 21st century, on the other hand, we have got coffee bots and robot baristas which can pour out a flat white but can't really process sarcasm. Imagine asking a coffee bot's voice user interface, make it strong, like my will to live. It would probably give you decaf. So we have gone from drawings of mechanical knights to coffee bots. That's the trajectory. But we are still missing something, because these robots, they are smart. They are just not human smart. And that's the difference I want to talk about today. I believe the robots of tomorrow will not just be efficient, they will be vitally intelligent. Vital intelligence is not just efficiency, it's not just data crunching, it's adaptability, it's collaboration, it's emotional context, it's intelligence that fits into life, not just into code. If a robot can lift 1,000 kilograms of weight but can't adapt to a child's trembling hand, it's not intelligent, it's just efficient. Great for a warehouse, not so great in a nursery. I study computer science at Heriot-Watt University, Dubai campus, and I spent the last semester asking myself, what is a robot? How can we make the robots of today much smarter to be the robots for tomorrow? This is mainly because I joined a research lab at my home university, Heriot-Watt. It's called LAIR, the Laboratory of Artificial Intelligence and Robotics Research. It's still beginning, but the questions it's asking, they're mighty big, mighty important. At LAIR, we focus on three main areas. First, AI-powered robotic automation, whereby robots don't just follow scripts but evolve from experience. Second, smart integration, whereby robots, with the help of sensors, hardware, and software, sync up together to form a living system. And third, human-robot collaboration, whereby we work with robots, we learn with robots, we share control, and we are not replaced by robots. Studies in human-robot collaboration have shown that when done correctly, when integrating real-time human feedback, they actually can improve task completion rates by up to 60%. That's not a tweak, that's a transformation. In our lab, we also study about cognitive robotics, whereby robots analyze the world around them and make complex decisions. This is important in areas like hospitals, disaster zones, crisis situations, logistics networks, etc. We study robotic manipulation, whereby robots can grip a glass of wine or a ripe tomato without crushing it. It's not just about strength now, it's about sensitivity, and that's quite important. The next one, we have actually broached this topic a bit earlier. This is called user-in-the-loop systems, whereby humans remain in the loop, where we work with robots. Robots only become an extension, not a replacement for human work. Furthermore, we also study in our lab soft robotics, whereby the flexible outer coverings of robots actually make it easier for humans to sort of navigate around robots, and they are incredibly useful in surgical procedures, in exosuits, etc. And finally, we research SLAM. This is a very new technology. It's called simultaneous localization and mapping, whereby robots can build maps of unknown areas and terrains while navigating through them in real time. Now that some of the scientific jargon is out of the way, let us take a deeper research-based dive. A 2024 study published in the Actuators magazine suggested that integrating deep reinforcement learning models involving pushing and grasping actions can actually significantly improve grasp success rate of collaborative robots by 87% and a task completion rate of 100%. This is more or less like how humans work. A deep reinforcement learning model means that a robot can actually learn from trial and error and perform significantly better than their traditional counterparts. This is the article from which I got that information. Furthermore, some studies indicate that integrating multi-sensory inputs such as haptic data, visual, auditory data, if you integrate it all together using sensor fusion technologies, these robots can actually enhance the situational awareness and contextual awareness of their surroundings. And this is very important. For example, a study in 2017 found by Rosen and colleagues actually suggested that if you used mixed reality displays to convey robot intentions, it can actually improve success rates by 62%, which, if you think about it, is not that small of a number. Robots have the potential for saving lives in a collapsed building, not because it is fast, but because it can feel its way through rubble without crushing what matters. And that's vital intelligence. This is the research we are doing right here in the UAE. Expo City Dubai and Heriot-Watt University have recently signed a memorandum of understanding to establish the UAE Robotarium, a national AI and robotics hub aligned with the We the UAE 2031 and the National AI Strategy. This platform is a place where tech industry, academia, and the government come together to build technological products that fit our region, our needs, and our future. I'm almost nearing the end of my talk. Let's go back to a few statistics. After all, numbers seldom lie. $275 billion is the amount that the global robotics market is projected to reach by 2025, according to DC Advisory's analysis of the International Federation of Robotics data. Furthermore, 2022 study by McKinsey Global Industrial Robotics Survey suggests that 25% of companies' capital spending will be spent on robots and automation. But the question we've got to ask ourselves is, are humans prepared to let robots invade our landscape? Are we prepared to work with robots? Think about that. Not because of faulty hardware, not because of erratic machines, but because we don't seem to get robots and robots don't seem to get us. Coming back to my original question. What is a robot? Is it a box of code? Is it a set of wires? Is it a moving machine? Or is it a mirror, a reflection of what we choose to value as a society? We have taught robots to land rockets, to drive cars, to write poetry. But have we ever taught them to really understand us? That's the next frontier. Vital intelligence matters now. Vital because in today's world, we don't need just logic, we need care. Intelligence, not just of the head, but of the heart, matters because this is not tomorrow's problem. This is for today. And now, because the systems we build today will impact the dignity of our lives tomorrow. Ask yourself, do you seriously think that robots will only be able to follow GPS coordinates in the future or lift heavy loads? No, they will be able to do much more than that. They will be able to comfort children when in need. They will be able to treat patients. They will be able to do much more, many more things. And that's the potential for robots in the future. But I must advise everyone with caution. Automating everything is not intelligence. That's just laziness with good public relations. For example, if Silicon Valley wants to sort of remove human workers and replace them with robots, we have to ask ourselves, who is better, a better worker or a better teammate? Second, Dubai is a pioneer of tech deployment, but I seriously wonder, are we supposed to build robots fast enough or are we supposed to build them thoughtfully enough? ChatGPT, while not a robot, can be integrated into robots. And ChatGPT can write you love poems, but can it ever understand the pain, the emotions, the sadness, everything that another human being can think or feel? I don't think so. Emotional intelligence is not generative. It's grounded in humanity. And that's what I seriously believe. Who's teaching robots to profile people based on skin color, accent, caste, creed, religion, gender? These sort of implicit biases do exist in today's robots because robots are a product of humankind. We create robots, and that is the main problem. What I'm saying is this: we have to overcome these problems. The next time someone asks you, what is a robot? Don't just tell them that it's a programmable machine capable of sort of doing a series of actions automatically. It is actually a question we are still answering. And if we get it right, it might just be the most human thing that humanity ever builds. I'm Isis Thomas Biju, and this was my TED Talk. Thank you.